This simple problem is on buoyancy. A 2.5 kilogram block with a volume of 2 times 10 to the power of negative 3 meter cube is totally submerged in water. The density of water is 1000 kilogram per meter cube. Calculate the buoyant force on the block. So the formula for buoyant force is buoyant force FB is equal to the density of the liquid multiplied by the volume multiplied by the acceleration due to gravity. The liquid that we're talking about here is water, and it has a density of 1000 kilogram per meter cube. And the volume here, since the object is fully submerged, it's totally submerged, therefore the volume of the liquid displaced would be this volume that is given here, 2 times 10 to the power of negative 3 meter cube. So that is our volume. That's 2 times 10 to the power of negative 3. And g here is the acceleration due to gravity, so which is 9.8. We put these values in the calculator, then we will have the buoyant force on the block is equal to 19.6 Newton, or approximately equal to 20 newtons. So if we are to illustrate this, if we have this block of metal, we'll draw the free body diagram. If it is on water, so the water is going to exert an upward force on the metal block, which is the buoyant force. And of course, we have the weight of the object, which is the force of gravity, or that's equal to the weight of the object, or mg. We would use this to answer the second question, which is what is the net force acting on the object? So the net force acting on the object would be the sum of the forces acting on the metal block. So we have the buoyant force, which is directed upward, minus the weight of the object, or the force of gravity, which is directed downward. So the buoyant force is positive, it's directed upward, and the force of gravity is directed downward. Now we substitute the values. So we have the buoyant force, which is 19.6 newtons, minus the weight of the object, which is equal to mg. So then we will have our F net would be equal to 19.6 minus the mass of the object, which is 2.5, times 9.8. Therefore, our net force is equal to negative 4.9 newtons. And the reason why this is negative is that the weight of the object is much greater than the buoyant force. So let's write that down. The weight of the object, Fg, is much greater than the buoyant force, and for this reason, the object will sink.